Okay, we're looking at section 3.3. We're going to go back and look at Chebyshev's theorem. I think that would be the most complicated topic in this section. I've already done the calculations. I just want to go through and explain how to get those calculations. The first calculation you have to make is the coefficient of variation, and all you do is you take the standard deviation and divide by the mean. Okay, and once you get that, you change it to a percent. And I took 37,000, divided it by 330,000, and I got my coefficient of variation. The next step is to calculate the z-score for a house that sells for 318,000. To calculate the z-score, you take your 318,000 and subtract it from your mean, which is 330,000, and divide it by your standard deviation. And when you do that, you will get a negative 0.32. Then it wants us to use the empirical rule, and we discussed this in the earlier video. Determine the range of prices that include 95% of the homes around the mean. If you remember that the empirical rule, 95% of your data values fall within 2 standard deviations of the mean. So what that means is you can take your standard deviation, multiply it by 2. So what that means is 95% of our home values are going to be between 74,000 above this and 74,000 up below the mean. So if you took 330,000 and added 2 standard deviations above it, your upper bound would be 404,000, 74,000 plus your mean. To get your lower bound, you subtract your 2 standard deviations. So 2 standard deviations below would be 74,000 below your mean, which would be 256,000. And then on the last part, Chebyshev's theorem. This is a little bit more complicated, but it's fairly simple if you follow the steps each time. On this one, they're asking us for the upper bound and lower bound, and we know the percent. So in order to get your basically your z-score, you take your percentage, you say 1 divided by 1 minus your percentage. So here 1 divided by, well, 1 minus 0.88 would be 0.12. When you get 1 divided by 0.12, you get, I believe it is 0.83, and then you take the square root. So you can look at your question help. You can view an example if you forget how to do this, because these are a lot of formulas and you will not see quite as many formulas on your test as you do on your homework. But if you look here and you have a percent, you can take your percent, and for example here our percent was 0.79, so you can take 1 divided by 1 minus 0.79 and take the square root. So that is basically how you get your z value. So our z value is 1 divided by 1 minus 0.88, which is 1 divided by 0.12, and you get your value and take the square root of it. So my z value is 2.887. So what that means is 88% of the homes should be within 2.887 standard deviations away from the mean. So if you take the standard deviation, multiply it by your z-score, just like we did here, our z value was 2. Here we had to find our z value, which is 2.887. Multiply it by that. Whatever you get, I believe I got 106,810. So you add 106,810 to get your upper bound. To get your lower bound, you subtract 106,810. And this is how you use Chebyshev's theorem. Now, we'll look at one more just to make sure. And just keep in mind as you're working your homework, write your formulas down so you can refer to those. I would expect you to know how to calculate the z-score, x minus x bar divided by the standard deviation, which means your x value minus your mean divided by your standard deviation. That's how you calculate the z-score. Let's look at question. Let's look at question 8. What is the mean? You can go into your StatCrunch to get the mean and the standard deviation. Since they didn't give us those values, calculate the interval x bar, which is the mean, plus or minus the standard deviation. So what we did was we took our value, which is our mean ended up being 25.5. We added 9.19 to get our upper limit. We subtracted 9.19 to get our lower limit, since it was one standard deviation away. What percent of the data values fall within the interval of x bar plus or minus s? Okay, so what we want to do is calculate the percentage of values that falls within this interval. So if we look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values that fall within the interval, and we have 18 total values. So if we divide 13 by 18, that would be 72%. What about for two standard deviations with the mean? You take the standard deviation, you times it by 2. So here our standard deviation is 9.19. If you times that by 2, you get 18.38. So you would add 18.38 to your mean and subtract 18.38 from your mean. And when you do that, your interval values would be these two. Now, how many values up here fall within this range? Well, it looks like that every value up here would be within the range except for the value 1. So if we did 17 divided by 18, we would get 94%. And then it says calculate the percent interval within 3 standard deviations of the mean. You would take the standard deviation, multiply it by 3, add it and subtract it from the mean, and this would be your interval. And then what percentage of the data values fall within this interval? All of these numbers up here would be in between these two numbers. Do these percentages agree with Chebyshev's theorem? Yes, they do. They all fall within the 100% range, so all the percentages agree with Chebyshev's theorem. Okay, on the last problem, there's several parts. Coefficient of variation, we know how to calculate. We take the standard deviation divided by the mean. So that's how we get 6.9%. The z-score for an MPA student who is 29 years old, you take 29, which is your data value, minus your mean, and divide by your standard deviation. And that is how you get the z-score. Remember, to get the z-score, you take your data value and you always subtract it from the mean and divide by your standard deviation. Using the empirical rule, the range of values that will include 95% of the students around the mean. You do not have to calculate your z-value. Remember, using the empirical rule, 95% of your values should fall within 2 standard deviations of the mean. So your z-value is 2. So you take 2 times your standard deviation, which is 2.4. 2 times 2.4 would be 4.8. You add and subtract that from the mean, and that is how you get your interval here. And then using Chebyshev's theorem, the range of the ages that will include at least 92%. Remember that formula, 1 over 1 minus 0.92, so 1 over 1 0.08, 1 divided by 0.08. You put that in, and then you take the square root of that. And then you will take that number, which I believe is 3.54, and you would times it by 2.4. You take your z-value that you calculated using your formula and multiply it by 2.4. Once you get that number, I believe you get 8.49. You will use that to add and subtract from the mean to get your interval notation. So when you're getting your interval notation, you're taking the mean and you're adding and subtracting from it to get that number.